Hi, here is our day one notes from ACT Prep, percent, proportion, and order of operations. Some of the parts of this you'll notice I go through kind of quickly because it should be some mainly review, but for some other parts it may be something that you may need a little more help with, so I'm going to talk a little bit more. For instance, up here at the top, we even call it the basics, turning percents into decimals and fractions and vice versa. So when you take a peek at this, and I'll put some little notes down here at the bottom, decimals, you've done this long enough that you're basically just going to be moving your decimal point 2 places to the left, because you'll know that if you don't see a decimal point, we assume it's right here after our last whole digit. 2 places to the left, 0.27. Fractions, and even though there's kind of help here, if you get to the decimal version and hit math, enter, any percent that you ever have actually is a fraction over 100. Now that might change a little. In this case, this one doesn't reduce. But as we move further, some of them may. For instance, when we get to the 73.8 again, 2 places to the left, gets me my decimal version. The fraction, now I'm not going to do 73.8 over 100. You may think, well, you just said everything's over 100, but we don't want decimals in our fractions. So to fix that, I'd move my decimal point 1 place to the right, making it 738, and if I move 100 1 place to the right with my decimal, I just add a 0. Ends up being 738 over 1,000, but they're both even numbers that can reduce. Again, here's where math, enter can help, or a reduce fraction button on your calculator if you have one. Just a mere 2 goes into each of these, so we end up down to 369 over 500. That's our simplest fraction form. And that can help a lot on testing because your answers will always be in their simplest fractions if there is one. Percent to decimal. This is one that always gets people because they want to put 0.6. But that only would be moving 1 decimal place to the left. I want to move 2, so I have to add the 0 in there for 0.06. Decimal version again, it's a whole number, it's out of 100, but once again, I can take a 2 out of these. Now it doesn't mean it's always going to be 2 every time. Maybe you'll take out a smaller number and you'll find out you can do it again. But if that's the case, that's fine. You can work your way through that way. So let's get into a few problems to actually work through with these. 45% to a fraction, okay? Any percent is always out of 100. But again, I have to take a closer look and say, does anything go into both of these? Yes, 5 does. So if I divide each of those by 5, or use my simplify fraction, I get the answer. 0.318 to a percent. Now I'm going from decimal to percent. I'm going backwards. So now I'm going to multiply by 100, or move the decimal 2 places to the right. So if I do that right here, 31.8%, and I'm good. Okay, 4/14 to a percent. Now some of you have heard of the percent proportion. You normally have your percent over 100. Well, in this case, that percent can become x. And if I cross multiply, and then divide by 14 in this case, and typically we're going to round to the nearest tenth, so we'll do it this way. Now some of you are like, well, I've seen a different way than that. Why do I have to do it that way? Because I've seen before that I could just do 4 divided by 14, I get a decimal, and then move it. Absolutely. But since I don't want to go through every single one of these, because I don't want to have you on here for like ever, I want to make sure that we get this set that way. So that's the way I'd go about it for this one. And again, the reminder over here for our percent proportion is there for you. So as we move our way up a little bit, now we're going to get to the dreaded story problems that so many people want to avoid. So I continue to look at this and I go, okay, Sam had $25 and gave 25% of that to Jennifer. How much money did he give her? 2 options here. Part of it would be, I could say I had $25, gave 25%, I could turn that into a decimal, multiply that out, and find it. But again, some of you aren't comfortable dealing with decimals and moving the decimal points around as much. So if that's the case, we can go back to the percent proportion. So we know it's 25%, so we know it's that over 100. But the question becomes, Sam had $25. Sam had all of it. So if Sam had all of it, that would signify 100% of the money. That's how I know the 25 would go down here. And Jennifer's getting 25% of it, so that's where the x would go. And just like up above, I would cross multiply and divide, and shock of shocks, I get the same answer. Okay? You're going to find out in this class there is no one right way to do things. You've got to find a way to get to the answer as quickly as possible. I mean, we're on a timed test here. So just something to consider. I receive a check for $200. Of that amount, I gave my friend $60. What percent of the check did I give away? Okay. I don't know the percent out of 100. I received a check for $200. It's all mine. So line that up with the 100 because this signifies what I have. I have all of it. I gave a portion of that, 60, to my friend. So you can always look at these fractions as part over all. Cross multiply. And divide by my 200, and we got to remember this is a percent, so I gave 30% of my check away. Dang, I'm pretty nice. I want to know that person. Okay. Another thing going along with percentages here can be a percentage of change. This can vary. It might not be the exact same every time, so be careful. The amount of change over the original amount. I was earning $18 an hour. If I get a $9 raise, what percent increase did I get? Well, how much of a change was there? If I now have a $9 raise, what do I make now? $27 per hour because I get $9 more. So the amount of change is my $9 raise. The original amount I was making is $18. So if I do 9 divided by 18, I get 0.5. So it's a 0.5% raise, right? Oh, I hope you didn't say right. Because I have to move it 2 places to the right or times it by 100. A 50% raise. I'd love to see a 50% raise. That would be fun, fun, fun. But since I can't make that much money, we'll just flip over to the back and start working here a little. Here's one of the things when we get into story problems that people have a big issue with, direct versus indirect variation. Direct variation is one part increases or decreases, so does the other. As I buy more, I spend more money. As I travel further, I use up more gas. You know, mileage goes up, the gas in my tank goes down. Versus indirect, whereas one part gets bigger, the other part gets smaller. So for instance, I look at doing jobs. If I'm doing a job myself and 2 more people start helping me, more people, less time. Travel faster. If I'm driving to St. Louis and I'm going 60 miles per hour, but then somebody else goes 80, they're traveling faster, they're going to get there sooner. Now I want to make sure, because I may have misspoke over here. Here, travel further, okay, costs more money, takes more time. I want to make sure that I didn't make that indirect. So for instance here, a stamping machine makes envelopes, 320 in 5 minutes. How long will it take for 480 to be stamped? Now again, we're going to split this off. You can set things up as a proportion. Envelopes in minutes, just like this. So in this case, I could say, okay, 320 envelopes takes 5 minutes. 480 takes how many? I don't know. I go ahead, I cross multiply, and I divide, and I get 7.5 minutes. Now what would happen if, for instance, all the answers were in minutes and seconds? Would this be 7 minutes and 5 seconds? No. Here's what I would have to do. To put it into minutes and seconds, oops, I better move up a little here. I'd have to do the 0.5 times 60, since there's 60 seconds in a minute. And since that would be 30, that would equal 7 minutes and 30 seconds. So I do have to be careful about things like that. Okay. Well, do you have an easier way? And some of you may say, yeah. Mr. H, why wouldn't I just do 320 divided by 5, which would be 64, and then I could do 40 divided by 64. Now, you could, but again, I think that starts to get a little bit tricky in here with all the decimals and other things you can run into. I really think it's easier with the proportion. But again, like I've said before, do it the way you think is best. Indirect variation. A lot of times with travel problems, how fast are you going? How long does it take to fill up something with liquid, or the types of problems these are going to be. Now I'm going to show you one way that might work, one way that doesn't work quite so well. So I'm going to scooch this up a little because I want us to be able to see the solutions down here at the bottom. So we're going 150 miles per hour. A plane's making a trip in 4 hours. How long will it take at 200 miles per hour? Now we're going to look easy, we're going to look hard. Some of you may say, well, I'll just do a proportion like this. So I was going 150 miles per hour and it took me 4 hours. And if I go 200, that should tell me how long it takes. So you start to work this out. And you're working through and you get 5.33 and you're like, this is sweet, and you go to look at the answers. I don't see that anywhere. What's going on? Let's use a little common sense for a minute. I was going 150, it took me 4 hours. I'm going faster now, right? 200? Should it take me longer or shorter of a time to get there? Shorter. Well, why is it taking me longer? Okay, this doesn't make sense. And the reason that is, this is an indirect variation. If I were to do a fraction like this, I'd have to flip the second fraction over to get things aligned correctly. Too many things to think about, too many things to get worried about. Let's make this easy. If I'm going 150 miles per hour for 4 hours, I have traveled 600 miles. That's my trip. So, if I'm going 200 miles per hour, the miles will cancel. 600 divided by 200 is 3 hours, which is one of my answers, and it's shorter than this. Whenever you're doing a problem like this, if you look and you say, well, I'm going faster, it's going to be shorter time than that, cross out the answers that don't make sense. Because in case you get that answer, then you won't be tempted to choose it, and then you can just basically move it down here and keep it simple. And finally, we've got order of operations, PEMDAS that you've been hearing about forever. Again, when you're doing these, especially if you have become calculator dependent over time, be careful because the parentheses can get you. For instance, if I were to type this into my calculator right now, there'd be a particular answer that I would end up getting. Actually, let's take a peek at that for a second. Most of you would just look at this and say, okay, let me type this in. 3 plus 8 divided by 2 minus 5 divided by 3 plus 5. And you'd hit this and you'd raise your hand and you'd say, Mr. Hardy, I am not getting the correct answer. What is going on? I'm getting 10.33333. Here's your dilemma. The calculator, when you go through and do a problem like this, and I'm just going to retype it because it looks like I got a little spot on my screen here. Hang on, sorry about that. We had a little technical glitch. But as you can see, I'm getting this answer of 10.333. Let me try to darken that up a little so you might be, whoa, a little over darkened. That's better. So you're like, what's going wrong? What happened? Well, what's going to happen? PEMDAS, it's going to do these two divisions first. It doesn't know that there's a fraction bar here. So what I always tell people is if there's a fraction bar, it's like having parentheses around each of those. So let's put parentheses around and see what happens. Then we get our division and we do parentheses again to let the calculator know, okay, I want all this done first, then I want this done. 0.25, winner, winner, chicken dinner. Okay? Again, I personally would rather do it on manually. I'd say, oh, division, 8 divided by 2 is 4. Plus 5 is 8. 3 plus 4 is 7. Minus 5 is 2 over 8. And then punch that in the calculator since everything's a decimal. But again, it's up to you. Second one, you can absolutely get away with going straight to the calculator if you want to. 4 squared is what? 8? No, 16. Multiplication and division become before subtraction. And we get the answer. So again, if you're still getting stuck, take a peek back through here. Otherwise, we'll see you with your homework tomorrow.